All right, this is section 7.3, triangles. And so the first thing we're going to do with triangles is we're going to use some vocabulary words and we're going to classify them. And there's two different ways that you can classify triangles. You can classify them by their side lengths, and you can classify them by their angles. So we'll look at the angles first. The four different ways that you can classify a triangle by its angles. We've got acute triangles, obtuse triangles, right triangles, and then a new one here is called equiangular triangles. So we'll start with an acute triangle. An acute triangle has three acute angles. So all three of these angles are smaller than 90 degrees. So less than 90 degrees is what an acute angle is. So all three angles in that triangle will be less than 90. An obtuse triangle will have one obtuse angle. You can see it's this one right here. Of course, obtuse means more than 90 degrees. And then a right triangle has exactly one right angle, and you can see it right here. So I need to clarify something real quick is an acute triangle has to have all acute angles. And the reason that all of them have to be acute is that in a triangle, you're always going to have at least two acute angles. In a right triangle, you have these two acute angles. In an obtuse triangle, you still have acute angles. So every triangle has acute angles, but only an acute triangle has three of them. Otherwise, it's an obtuse or a right triangle. Now, if your acute triangle happens to be a triangle in which all three angles aren't just acute, but all three angles are congruent, which we know congruent means equal measure, they're the exact same, then we call it an equiangular triangle. So you can see that word equa means equal and then angles. And so if you think about it, and we'll talk more about this, but if a triangle has 180 degrees in it, which you may or may not remember that from previous years of math, but if I split 183 ways, 180 divided by 3 is 60. So an equiangular triangle has three 60-degree angles because they're all the same. So it's an acute angle or acute triangle, but it's a special kind of acute triangle where all three angles are 60 degrees. The second way we can classify triangles is by their sides. And so you might remember hearing these words before. We've got a scalene triangle, isosceles triangle, and equilateral triangle. And so a scalene triangle is a triangle that has no congruent sides. No sides are equal. They're all different. So this could be 7, this could be 8, and this could be 9 or I don't know, maybe it doesn't look like it's 9, maybe it's 6, right? They're all different sizes for the sides. An isosceles triangle, which looks like isosceles, but it's actually just isosceles, has two congruent sides. So it could be the top two sides or really any two sides. And see these red tick marks or arcs on the angles. If you actually look up here for this problem here, you can see that they used arc marks. So those red arcs or the red tick marks indicate congruent sides and angles. So it shows you which ones are equal. So in an isosceles triangle, these two sides are the exact same. And then an equilateral triangle has all three sides being equal. So again, that was scalene, that has no congruent sides. Each side is different. An isosceles triangle, which has two sides being the same. And then an equilateral triangle has all three sides equal. So let's practice classifying these triangles by their angles and by their sides. So in example A, we have a triangle that has three different angles, but one of them is an obtuse angle. So this has to be an obtuse triangle. And then you'll notice none of the sides, they didn't use any of these red tick marks that you see in the other problems. They didn't use any of those red tick marks, so none of the sides are equal either. So this must be a scalene triangle then. So remember, scalene means no sides are equal. So I have to classify it by its angles. So that means acute, obtuse, right, or equiangular. And then I have to classify it by its sides, which means scalene, isosceles, or equilateral. So you have to give both words. I'm looking for two answers for each problem. For example B, you can see these two sides are the same. So it has to be isosceles. And then all three of these angles are acute. We don't know what their angle measures are, but they don't appear to be right angles or obtuse angles. So this would be an acute isosceles triangle. Isosceles. For example C, we've got clearly a right angle here, so we know this has to be a right triangle when I'm classifying it by its angles. And then two of the sides are equal again, so we know from our previous problem that means it's got to be isosceles. So right isosceles triangle. And then for the last one here, we've got all three angles are acute, all three angles are also equal. So you could say that this is acute, or you could say it's equiangular. I think I can fit this on here. Equiangular. Handwriting's kind of sloppy there. And then all three sides are the same as well. So not only is it equiangular and all three angles are equal, you can see the little angle marks showing that these three angles are all the same, but the three sides are equal. So it's equiangular and equilateral. Let me scoot this over a little bit. Equilateral. Okay, so you could say it's acute equilateral or equiangular equilateral. I believe that your homework questions are going to ask you for these two specifically. Even though it is an acute triangle, it's more specifically, you could say it's equiangular. Okay, so example E then. For example E, we've got another right triangle. So we know it's a right triangle. Again, I know it's got acute angles. Every triangle has at least two acute angles. So you can't just look at a triangle and say, oh, here's an acute angle, it must be acute. In order to be an acute triangle, all three angles have to be acute. So it's right, and then none of the sides are the same. So this is going to be a right scalene triangle. And then for example F over here, we've got two of the sides being the same. And then it's a 100-degree angle there, which is obtuse. So it's obtuse isosceles, since two of the sides and two of the, actually, and I didn't even point this out yet, but every isosceles, there's a relationship in triangles that every triangle that has two sides that are equal will have two angles that are equal as well. So you'll notice an isosceles triangle doesn't just have two equal sides, it has two equal angles as well. And then if you have a triangle that's scalene and doesn't have any equal sides, then all three of the angles will be different as well. So if it has three different sides, three different angles. If it has two equal sides, it has two equal angles. And if it has three equal sides, it has three equal angles. That's a lot of purple there. But three sides are the same, then three angles will be the same as well. So I'm just going to jot that down here. Again, as I just mentioned, if a triangle has three congruent angles, it will have three congruent sides. So every equiangular triangle has to be equilateral then. Has to be. I forgot an A there, equilateral. No, that looks bad, but oh well. And then if it has two congruent angles, it will have two congruent sides, which makes it isosceles. And then if it has no congruent angles or zero congruent angles, it will have zero congruent sides, which would make it scalene. So every scalene triangle has no sides that are the same, no angles that are the same. Every isosceles triangle has two sides that are the same and two angles that are the same. And every equilateral triangle has three equal sides and three equal angles. All right, this is just some extra practice classifying our triangles by angles and sides. So in example A, I have an acute triangle because all three angles are acute here. And then you'll notice they didn't give me any angle or any of the red tick marks on the sides. However, knowing what we just talked about, I know that I've got two congruent angles, which means I will have two congruent sides, and therefore it is isosceles. So these problems they're not more difficult, but they are stretching your vocabulary a little bit. These two sides right here are equal. I know that because they're across from these 70-degree angles, so they have to be the exact same. So again, that relationship says if you have two equal angles, you will have two equal sides, and so I know this has to be an isosceles triangle without even having the tick marks on the problem. In example B, we know this is a right triangle because of the right angle. There is no tick marks, there's no angle measures here, so I can assume they're all different, and that makes this a right scalene triangle. In example C, I've got an equiangular triangle. It's also acute, but we'll say equiangular. If I could spell, that would be nice. Equiangular. There we go. And then if I have, as I just mentioned previously, right, if we just address this, if we have three congruent angles, we'll have three congruent sides, which means this equiangular triangle is also going to be equilateral. And again, that'll always be the case. Equilateral. Every equiangular triangle will be equilateral. In example D, we have an obtuse angle here. So I know it's got to be obtuse. It's larger than 90 degrees. And all three angles are different sizes. So all three sides will be different sizes, making this scalene. And the last one here, example E, I've got the angle measures and the tick marks that I can look at. And so they give me 1 tick mark, 2 tick marks, 3 tick marks. That means none of these sides are the same. They all have different measures. And I can prove that because all three angles are different. So if all three angles are different, all three sides are going to be different. So this is totally a scalene triangle. And then are any of the angles 90 degrees or larger? No. One is close, but it's only 85 degrees. This is an acute triangle. So it's an acute scalene triangle.